Okay, so we already talked about the first half of glycolysis, which is where we invest energy into the system in order to get more energy out. But reactions 6 through 10 are going to be the energy production steps. So overall, what happens is two molecules of that glyceraldehyde 3-phosphate, what we formed in step number 5, or 4 and 5, but are converted to two molecules of pyruvate. So in this process, 4 ATP are produced. So we had 2 ATP were invested at the first half, but now we have 4 ATP produced. And you might look at this here, this cartoon here, and be like, well, I only see 2 ATP are produced. But remember, this whole process, steps 6 through 10, happened 2 times because we have 2 molecules of glyceraldehyde 3-phosphate that were formed. So let's look at these steps a little bit more in depth. So reaction number 6 is going to be an oxidative phosphorylation reaction. So it's an oxidation and a phosphorylation at the same time. So what you'll notice is this aldehyde here gets oxidized, but not just oxidized to the carboxylic acid, but it's also oxidized to the carboxylic acid connected to a phosphate. So that's what I mean by phosphorylation and oxidation. So that group now looks like this, where we have that oxygen and the phosphate on there. This process occurs through coenzyme NAD+. So NAD+ and a free phosphate floating around. So this time the phosphate is not from ATP, but it's just a phosphate that's been used and cleaved in another process, is then added into this molecule. So the enzyme for this is a dehydrogenase. So dehydrogenase, meaning we're taking hydrogen away, that couples with the NAD+ coenzyme. So the NAD+ is what actually accepts that hydrogen so that the enzyme catalyst can make sure it keeps its same structure. And then this makes a high energy compound 1,3-bisphosphoglycerate, which is this molecule here. So this is kind of like the peak of our energy production, in terms of now we're going to go, this high energy molecule is going to produce energy. So step number 7 is a phosphate transfer reaction. So that molecule we just had, this molecule here is the 1,3-bisphosphoglycerate. And you notice that all we're going to do is remove the phosphate that was here. There was a phosphate, now there's not. In doing that, we make an O- charge, and we produce ATP. So when we do this process twice on both molecules, we get 2 ATP out of this process. So it's important to remember, reaction number 7 produces 2 ATP. So this overall balances. Now we're at equal energy overall between reactions 1 and 3 that required ATP. Now we've donated that back in. So we use an ADP to produce an ATP. We're transferring a phosphate group from that 1,3-bisphosphoglycerate, the product of step 6, transferring a phosphate group to ATP to make that ATP that's going to be used. So again, this is going to be a kinase because we're transferring a phosphate group. Step number 8 is going to be an isomerization reaction. So the 2 of those three phosphoglycerate molecules, there's 2 of them, isomerize, moving the phosphate group from carbon number 3 to carbon number 2. So as you see here, we have an OH on carbon number 3, 1, 2, 3, and the phosphate up there. So our isomerization reaction releases water and transfers the phosphate group up. So kind of a lot happens in this. Oh, sorry guys. Go away. Thank you. Oh, I'm sorry. I got ahead of myself. Got confused. There we go. In the molecule up here, the phosphate is on carbon number 3. I got mixed up because I didn't see the first structure. 1, 2, 3. There we go. You see that the phosphate is on carbon number 3, and then we isomerize using, it's called a mutation, isomerase. You move that phosphate from C3 up to C2. So that's what's happening in reaction number 8. And then we do a dehydration reaction. So we're moving that phosphate in order to remove water from the reaction. So let's change our colors to be clear. This OH here and this H here are what forms water. Those 3 atoms together form water. And then your result is a carbon-carbon double bond. This is catalyzed by an enolase enzyme. An enol is a special kind of structure where there's an ene or an alkene next to an ol, which is an alcohol. So you can see it's a phosphorylated alcohol, but we have an ene next to an ol, so it's an enol. You don't really need to know what an enol is, but that's why it's named as such. But we're going to use that to make 2 molecules of water. And then again, this molecule here is going to be a high energy molecule. So that means it's going to be about to be donating molecule or donating energy. So this is phosphoenol pyruvate is that molecule here. Our last step in glycolysis is going to be a phosphate transfer reaction. So we take again our phosphorylated process or our phosphorylated triose and or I guess it's not a triose at that point, it's a pyruvate, but phosphorylated molecule, and we donate those phosphates back to an ADP molecule. Let's go back to purple. ADP makes ATP. This happens twice because we have 2 of these molecules going through the system. Again, this is a kinase reaction, a phosphate transfer reaction. All we're doing in that is getting rid of our phosphate. It actually moves where that double bond is, but that's inconsequential at this point. And we make pyruvate. So this is the product of glycolysis, are 2 pyruvate molecules that can then go into other processes, which we can talk about in a minute. But so the overall reaction of glycolysis, there's 10 steps to it. But if you just take all of those steps and put it into a general reaction and cross everything out, we have 1 molecule of glucose. We need to put in 2 ADP, 2 phosphates, and 2 NAD plus coenzymes, but we get out 2 pyruvate molecules, 2 ATP. So we're producing overall 2 ATPs. And then we also have the oxidized versions of NADH. So learning check. In glycolysis, what compounds provide phosphate groups for the production of ATP? So which steps and which compounds produce ATP? What are those high energy molecules that are going to produce ATP? So that is going to be, if you look back in your notes, step 7, which is the molecule 1,3-bis phosphoglycerate. And then in step 10, where the substrate is phosphoenol pyruvate. Okay, so we have a question here. Why do we even care about pyruvate? I keep saying we make 2-pyruvate. That's great and all, but what does that even mean? Well, we'll talk about it in our next video.